So we're going to begin first with sets and cardinality. So just some like basic front information before we do examples. Remember, a set is a collection of objects. And there are two aspects of it. Number one, order does not matter. And then number two, no duplicates. Right, so no duplicates in a set. We only have one of those objects, right? So that's what a set was. We can describe a set using many different ways, either using what we call like roster building notation, intervals, the curly brackets, or we can just describe it in words. But for the most part, we're going to look at just kind of the curly brackets or either that or just describing them because they're too big to be able to do that. All right. And then we have three major set operations. So the first one was the union. So that's going to be A union B or A or B, right? Which is an element in A or B or both, right? And if we draw that as a Venn diagram, if this is A and this is B, then the A union B is just all of that shaded in like that. So A union B, right? So that was the first one. The other one is the intersection. So that's A intersect B or A and B. So the and is the word for that, which is an element in A, sorry, both A and B. Okay. Let me make it, which is all elements, and which is all elements in A or B. So from the Venn diagram perspective, that's not any better, but that's okay. That's just going to be like this little region right here. So A intersect B. And then the last one was the complement. So the third one, the complement. So A prime or AC, which is all elements not in A, right? So if you draw like a little box that represents everything, and then you draw a circle, give you A and B, and this is A, then everything outside of the circle is the complement. Like that. So that's AC, right? So those are the major three. Do know those because they are important. And then from that, we talked about cardinality, right? And these pictures that I've drawn right here are called Venn diagrams. So this is a Venn diagram. And then the square is called the universal set, which is basically the big set, the one that contains everything. So thankfully, its name is very descriptive of what it does. So let's just do an example. Well, actually, I got to define cardinality first, so let's do that. And then the last thing, the last major thing was the cardinality. Actually, you know what I can do? I can do this. Let me make this. Put that right there. And then I could just all have this on one slide so it looks a little bit nicer. Okay. Yeah, so the cardinality of a set is the number of elements in the set. And so the way we abbreviate that is N of A. So that's kind of the notation that we use. The number of. So you can think of the letter N as the number of. I mean, it's kind of that literal in a way. So that's the cardinality, right? And those are the main things that we talked about. There's like one little other thing, the formula that we'll talk about afterwards, but the first thing that we want to be able to understand is just, finding sets and finding the cardinality, okay? Most of the time, what they focus on more is the cardinality, just because that's just typically what they like to focus on from my experience. So here's an example. And this is straight from the review. So this is actually number 15. So the first question that they ask is, what is the cardinality of A union C? So that's the first question. And if you notice the screen is going gray, that's just me screen clipping, so it's nothing on your end. Okay, so with this problem, first thing I would do is find A union C. So let's just find what that is, right? So remember, union means or, okay? And let's write this over here. If you're doing a union, sets get bigger. Sets get bigger. And then for intersection, sets get smaller. Like that. And then for complement, there is no rhyme or reason. It could be one or the other. So A union C. So I like to stack up my sets. So we write the names down. And then C. One thing is make sure that you actually look at the correct letter. Like that. Okay. And then we want to find the union. So the union is basically just adding the sets together and then getting rid of the duplicate. That's actually kind of what you're doing. I would not say that officially. We're just going to combine them together. So I just go one by one. So Dirk, Franz, Johann, sorry. And then I go to the next set. So done, 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 done. I already used Franz, so no. And then Tina. So I write down Tina. Okay. And there it is, right? So that's the union. And then step 2 is just count now. Count for N of A union B. So N of A union B is equal to 1, 2, 3, 4, 5. So 5. And there we go. Any questions on that? All right, so the next example that we're going to do is this one. So this one has the complement in it, so we'll have to take that into consideration. So step 1 is to find, so first I would find the complement. So find B complement, right? And so in order to find B complement, right? So the complement is always relative to the universal set. So S right here is the universal set. That has everything. So B is B, and then B complement is everything that's not in B, but in the universal set. So if I were to write down B, okay, so I'm just writing it down. Again, you don't have to do this, but that's going to be Franz, Enrica, Laws. Sorry. And let me give myself a little bit more space. Tina. Okay. And then the complement is just everything that is not what I have above me. Okay. So if I look at the universal set, I have Arthur, right? So Arthur is allowed. And just to like make this, I guess, as obvious as I can, I'm gonna copy this over right here. Okay. And I'm gonna paste it relative to ours. So right here, we're comparing that to B. So Arthur, good. Dirk, good. Franz, nope. And then Henrika, nope. Johann, yes. Claus, nope. Sorry, nope. Tina, no. So those ones don't work because I already have them in B. And remember, B complement is everything not in B. So that's the key. Okay. So then step 2 is to find the intersection of A and B complement. So A is equal to, well, it's Dirk, Franz, Johann, and sorry. And then B complement is just Arthur, Dirk, and Johann. And so when you do the intersection, your set usually, there are cases where it doesn't, but most of the time, it will get smaller. So if it gets smaller, because they don't always share the same thing, right? So they both share Dirk, so I'm just gonna highlight that for you. So Dirk, actually, I'm gonna use a different color. I liked blue today, so we'll do lavender. Dirk, Dirk, and then Johann and Johann. Those are the only ones that they share. So I do Dirk and Johann. And then step 3 is to count for the cardinality. Oops, wrong symbol. And so we get the intersection of these two is 1 and 2, so 2. And that matches my answer. So yep. Okay, so doing the last one. And so one thing to remember is that when you're doing set operations like these, order of operations is still in place. So you do the inside of a parentheses and work your way out. So for this one, what is the cardinality of A intersect B complement? So I am going to first find the intersection and then find the complement of the intersection. Okay. So I'm just going to copy the sets over so I have them right there. So let me copy this over. So A and B, like that. And so step 1 is going to be to find A intersect B. So you do basically an order of operations. And so because it's an intersection, all you have to do is just find out which ones overlap. So just highlighting. They don't have Dirk. They both have Franz, like that. Don't have Johann, and they both have Sorry, right there. So those are the two that they share. And so A intersect B is equal to Franz and Sorry. And then step 2 is to find the complement of that. So A intersect B, complement. Okay. Now, fun fact, there actually is a way of distributing that complement, and it actually has a name. It's called De Morgan's Law. So he was a famous mathematician in set theory, and he actually figured out a way of distributing the complement. So if you wanted to, you could actually do A complement union B complement. But the only reason I wouldn't recommend doing that in this case is because then you'd have to find the complement of 2 sets and then find their union, which I think is more work. But theoretically, you could distribute if you wanted to. Okay. So there is S, and then our intersection is A intersect B equal to Franz and Sorry. And so the complement of that, so the opposite, is basically don't want Franz and don't want Sorry. So everything else is okay. So Arthur, okay. Dirk, that's okay. Franz, nope. Henrika, that's okay. Johann, that's okay. Claus, that's okay. Sorry, whoops, let me put check marks on these. So Franz was not okay, Henrika was, Johann was, Claus was. But sorry is not okay because we already have it in our other set, and then Tina is okay. And there we go. So now we have the complement, and then step 4 or 3 is to count. And if you think that the amount of work I'm showing here is too much, that's fine. Because technically, some people can see it a lot faster than others, and that's perfectly fine too. So, do as much work as you need for yourself to be able to convince yourself like that's the correct number, right? So 1, 2, 3, 4, 5, 6. So the cardinality is 6. Like I said, some people could be like, okay, A intersect B. So I got Franz and sorry. Those are the only two. That means the complement is everything but that. So that's 1, 2, 3, 4, 5, 6. That's the answer, right? Like you could do that. It's just some people aren't as good at seeing the sets like that. So writing them out is very helpful. So we're going to do an example from the homework. I'm just going to change the number to make it a little bit more interesting. So determine the cardinality of the set of all the outcomes of rolling 2 distinguishable dice that add up to, let's do 6, okay? So here you have to think about it just a little bit more logically. So step 1 is find your set. So find set. And you can call it whatever you want. We'll just call it A, find set A. Oh, they call it E. So E is going to be equal to roll a 6, which means because they are distinguishable, that means 1 comma 2 does not equal 2 comma 1. Those are different, okay? Because one may be blue and one may be red. If they were indistinguishable, 1 comma 2 would be equal to 2 comma 1. So that's the difference between distinguishable and indistinguishable. It's like when you play a game, if you roll 2 white dice, you can't tell if they like rolled too much, which one was which originally. But if you roll a red one and a blue one, you can always tell which is which because one is red and one is blue. So they have to add up to 6. So the first one I think of is 1 comma 5 because 1 plus 5 is 6. Then 2 comma 4 and then 3 comma 3. Okay. And then I think 2 comma 4 and then 1. Sorry, I already did that one. 5 comma 1. Okay. And then so I got 1, 2, 3. I need 4 comma 2. Actually, I went the wrong way. So 4 comma 2 and 5 comma 1. So I got 2, 4, 4, 2. Actually, I did that one twice. That's why I confused myself. 4 comma 2 and then 5 comma 1. There we go. I wrote the same one twice is where I messed up. Okay, so do I have all of them? 6, 6, and 6, and 6, and 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, I have all of them. Now, if you're wondering, why is there only 1, 3, 3? Because there's only one way you can roll a red 3 and one way that you can roll a blue 3. So 3, 3 is the only one that doesn't have it twice. And that's the same for all dice. 1, 1, 2, 2, 3, 4, 4. All of those, they only have one roll. Okay? And then now we just count. Step 2 is to count. So the cardinality of E is equal to 1, 2, 3, 4, 5. So it's just 5, right? So one thing that you're going to have to be careful of is you're going to have to read the problem. If I ask for a probability, that's where you're going to divide and give me a fraction. If I ask for like a cardinality, I just want the number of things in there. So one very important thing is like, because I've seen people where they think it's a probability problem, but it's actually like a cardinality problem. So just make sure that you pay attention to that. Okay. And then one last thing. So here's another example. Let A be equal to 1, 2, 3, and 4, and B be equal to 5, 7, and 9. Okay, find the intersection of the two. If you try to find the intersection of two sets and they do not share anything, then we call that empty. So they don't have any numbers together, so it is empty. So the empty set. The word that we actually use is called mutually exclusive. They do not overlap on the Venn diagrams. All right, so the other big topic that was related to 7.1-7.2 was the principle of inclusion-exclusion. Apparently, it has an abbreviation, which is just PIE, so PIE, principle of inclusion-exclusion. And all that says basically is like if you're trying to add up how much you have of something, specifically if you're trying to find the cardinality of the union of two sets, okay, then effectively you just add up everything you have in A and you add up everything you have in B. But the problem is if they overlap, you've basically added up too many things. You've double counted, which in counting is like the most bad thing you can do. It's like the cardinal sin of counting. We got to subtract out where they overlap, right? So effectively, if you draw like a Venn diagram and you draw A and you draw B, if I count all of A right here, and then I count all of B right here, the problem is you've counted that middle region twice, so we have to subtract out the double counting. That's what that formula does. It just subtracts out the double count, which is really important, right? And so generic problems I can ask you is like, I can just give you part of the formula and you tell me, hey, what is the missing part, right? So this is an example from the review. So let's do this one. So step one, write down the formula. And so a question you might ask is, how do I know to use the formula? If you just see like this and this, that automatically means use the formula. Is there any other formulas that you need to know for this type of problem? No, there isn't. You could do it for bigger sets, but we're not going to do that in this class. But in case you were curious, if you wanted to do it for 3 sets, and I'm just going to show it to you in the video, but not leave it in the notes, that's what the formula would look like. It's just you have to add up all of them, and then subtract out where they overlap like 2 circles at a time. But then the thing is, you actually subtract out too much, so then you have to add back in the little tiny part where they all overlap back in. So that's if you want to do 3. And then there's actually an even larger formula if you want to do it for like 20 sets, or like you can just keep going forever. But that formula you don't want to see; it's too complicated. So we use our formula. Minus the intersection. Key thing is just don't get these mixed up. Like don't put the union and the intersection backwards. I've seen people do that. Just got to memorize the formula. And then step 2 is just to plug in, right? So we just got to plug it in. So plug in. So they told us this right here, right? So 80 is equal to 50 plus 40 minus the intersection of A and B, right? So just simplify. And so we get 90 minus the intersection of A and B. And so I could subtract over the 90. And I get -10 equals negative n of A intersect B, the number of A and B. And then divide by -1, because they're both negative, and then there it is. One thing to note, and this is very, very important, and I'll write this at the very beginning. Okay, where is it? Cardinality. Actually, I'll right here. All answers will be positive. And not fractions. So if you're doing cardinality, you have to get a positive number and it can't be a fraction. So basically a whole number, including 0, which the whole numbers does. Okay, so that's the nice thing is your numbers, they always work out nicely. They can't be anything bad. So there is a problem kind of like this in the homework, but we also did one in class just like this, and I think this is just a good problem. I'm going to probably do 2 of these. So basically what I'm asking you to do is just like figure out how many are in A or B here. So I want you to use this formula, but I am not going to actually tell you which one is which directly. You kind of have to figure out what it is, right? So Step one is first just find, write down the formula. So if you're talking about cardinality and you see the word or and, you automatically want to use this formula because it's the only formula you actually kind of have at this moment. And pretty much for the entire exam of cardinality, like this is the only one that you can use. Okay. And then step two is I would draw a Venn diagram now. So a Venn diagram. So your Venn diagram will have a box. So that's going to be everything. And then we call that S for the universal set. And then we're going to have two circles, one here and one here. Okay. And so from there, we just need to figure out how much each circle has, each little region, right? So we're going to call this A and we're going to call this B. Okay. And that's the basic principle. And so I'm just going to make this bigger just so that I have more room to write. Okay, like that. And so they tell me that set A contains 304 elements. So A, the cardinality of A has 304. Okay, that's what they tell me. And they tell me that B, okay, the set B contains 448 elements. So the set B is equal to 440, right? And they say if set A and B have 61 elements, so that you see the word and, that means this little region has equal to 61, okay? Do you have to draw the Venn diagram? You actually don't. This is just helping you visualize what's going on, right? So this is A and this is B, and then that's the intersection of B, okay? Actually, I'm not going to put it in there because that could be a little nuance. And then step three is to plug in, okay? So n of A or B, right? So they say, what is the total number in A or B? And so we plug in 304 plus 448 minus 61. And if you plug that in correctly, you're going to get 691. Okay. And that's it. So you might think, is the Venn diagram necessary? No, in this case, it's actually not. But there are problems where maybe I want to know how many elements are just in A, right? So like, what if I wanted to know? So this is like a follow-up question right here. B, how many elements are just in A, right? How many are just in A? Well, I know that A, so the cardinality of A is equal to 304, right? But that's the entire circle. If I want to know just A, so that would be like this part of the circle, okay, I would have to subtract out where they overlap. So then the shared elements is equal to 61. So only A is equal to 304 minus 61, which is equal to 243. So this is 243. This is 61. And then if I wanted it for B, okay, so then I could do 440 minus 61, and that would be 300 and let's see, 79, right? So that's how many elements are in each little circle, right? Again, maybe a problem doesn't ask you to do that, but in the event that they do, they could. And so here's a great question that I think kind of reinforces the use of the Venn diagram. Okay, so we're going to do this example. And then we'll see if there's any other ones that I want to do, and should be good with 7.2, 7.3, 7.1, 7.2. So the Phoenix School District services the elementary and middle schools in Phoenix. 32 teachers are teaching in Phoenix, and 83 are teaching in middle school. Sorry, first was elementary, second was middle school. If 12 teachers teach at both, what is the total number of teachers employed at the district? So I just want, how many total teachers are there, right? So step one is formula. So N of A union B equals n of A plus n of B minus n of A intersect B, right? And then step 2 is a Venn diagram. Another thing the Venn diagram helps you do is it also just helps you label things. So that way, when you're drawing it, you know what is what. So this will be elementary, and this will be middle. So I am told that elementary has 32. So this big circle is 32. I'll just write that elementary. And then this is middle. And so middle school is 83. And then if 12 teachers teach at the school district, that at both, I have 12, right? And so what a student could do accidentally, and this is the reason that I mentioned this. So I'm going to do n of E elementary, and then n of M for middle, is they might just add up all the numbers together. But if you just add up all the numbers, the problem is you've essentially double counted because there are 12 teachers that teach both, right? So again, you don't have to do this, but could there be a question maybe on the exam where they're like, fill out the Venn diagram? Because we did have an example of that on the homework. Sure. So this is what we're doing. We're just filling it out. So 32 teachers taught taught elementary. Now, here's something important because this comes down to English and logic a little bit. If I say 32 teachers teach elementary, they could also teach other things. The only condition for that statement to be true is that they're teaching elementary. So this part of the circle right here that I've outlined is the teachers that only teach elementary. So if you do 32 minus 12, that is 20 teachers that only teach elementary. Okay. So this right here is only elementary. And then 83 minus 12 is 69. And so that's only middle school. And then from there, we can just plug into the formula. So plug in. So you could do it two ways. You could add up the 20, the 12, and the 69. So I could just do that. But if you just plug it into the formula, okay, so what is the total number of teachers employed? So it would just be this, which is equal to 32 plus 83 minus the 12. And if you add those together, what you're going to end up getting is 103. Or you could add up 20 plus 12 plus 69, and that too is equal to, did I do that right? 103. All right, let me make sure I'm looking at the right problem. Okay, I noticed my mistake. It's you're probably watching the video like that. Isn't that wrong? No, it's 71. That's where 71. So a different interpretation, right? As long as you're not double counting, you can add things up. So that's one way of doing it. But fundamentally, the formula takes care of it. So that's why we like this formula, because I don't have to think about it that deeply. As long as I know how much is in one set, how much is in the other, and how much they share, the formula will always take care of it, right? But what I want to show you from this example more than anything is just how to set up a Venn diagram too, right? Any questions? So when it comes to this problem, my recommendation is probably just use the formula. But if the problem requires you to use set up a Venn diagram, then you could use the Venn diagram to your advantage. But ultimately, if you want to just take the path of least resistance, just use the formula, plug in the numbers, and you're good to go, right? So the formula will always take care of it. Just in the event that they do ask you a Venn diagram problem, I want you to be able to use it and utilize it. Okay, so here's just one more Venn diagram problem. This was kind of like similar to the last homework question, but they just gave you a little bit more information. This one is just, I give you all of the information that you need. And so all you have to be able to do is just fill out the Venn diagram. So I would probably just label these as like science, history, and psychology, right? And so the key here is just work inside out. So work inside out. So first determine how many students took all three classes. So I see all three classes right there. So that's going to be 280, right? Because they all took three classes, right? And then from there, you're going to now do these right here. So you're going to basically look at the intersections of two of them. So history and psychology right here, history and psychology. So that's going to be this one right here. And I am told that these two have to add up to 563. So 563 minus the 280 that already have taken both, right? Let me just make that a little bit easier. So 563 minus 280. That's going to be equal to 277. And I'm going to verify that before I continue. That does not look right. So let me just do it. 563 minus 280 is 283. So not even close. 283. So those are the students that took history and psychology, but not science, right? So that's what that means. Okay. And then they tell me, okay, the next one is history, sorry, science and history. So that's going to be this one right here. So I know that 638 students took science and history, but I have to subtract out the 280 that took both. And so if I subtract those two, I end up getting 358. 283. Actually, let me go back to my color. And then I just keep going, right? I just keep going in this circle. So then we go to the next one. And so the next one says, okay, science and psychology. So that's going to be this one right here. So we do science and psychology. So 675 minus the 280. And we get, so 675 minus 280, 395. And there it is. And then now I know how many students took science, history, and psychology. So I'm going to use all of those numbers, right, to basically find science, history, and psychology only. Like they only took a science class, they only took a history class, and they only took a psychology class. So science is going to be equal to 1351 minus the 358 minus the 395 minus the 280. And if I calculate that correctly, you're going to get 318. So 318. And then if you do history, that's going to be 1140 minus 358 minus 283 minus 280. And so if you do that correctly, you're going to get 219. Okay. And then the last one is psychology. 1326 minus 283. I'll do 395 minus 283 minus 280. And if you do that one correctly, you're going to get 368. Okay. Now, if I add up all of these numbers, so if I sum of all regions, that would be equal to, so you add up all of them, you're going to get, let me find it real quick. It's in the problem statement. They tell you that it's 2427 right here. And then if you want to find out how many students took none of the classes, sorry, so we already know how many all, so none would be equal to 2427 minus, okay, actually, no, I apologize. We know how many total students took it, so total that took class, so total that took class is equal to sum of all regions. So I was right. And if you give me 1 second, I will calculate that. So it's going to be 2, 2, 2, 1. So basically that's all of the circle regions added up. And then if I want to find how many students took none, that would be 2, 4, 2, 7 minus 2, 2, 2, 1, which is equal to 206. So the actual number of students who did none of the classes, they didn't take history, psychology, or science, there's 206 students like that. So if you feel comfortable filling out this Venn diagram, then you've mastered the Venn diagram, right? So then I could just ask you questions like, well, how many students did history or psychology? So history would be this circle, or psychology would be this circle. So then I find where they overlap and I just add those two numbers together and that's my answer, right? So do I think they'll ask you to do a 3 Venn diagram on the exam? No, because honestly, it would just take too much time. But a 2 Venn diagram, sure, that's always plausible. If I gave you a 3 Venn diagram, I'd probably just fill out most of it, if not all of it, and then you could use that to answer questions if necessary.